Hey there, data enthusiasts. Ready to really get into Apache Spark. Today we're going to explore this powerful data processing tool, and to really make it interesting, we have a unique twist. Think fast-paced action, electrifying rivalries, larger-than-life characters.
Yeah, we're talking WWE. We'll be using analogies from the world of professional wrestling to break down these concepts, making this one deep dive you won't forget.
What's so cool about Apache Spark is it's designed for large-scale data processing. So imagine mountains of data. Spark is your heavy lifting champion, capable of sorting, analyzing, and making sense of it all with remarkable speed and efficiency. It's like having The Rock and John Cena team up to handle your data challenges, right? Exactly. It's a game changer in the world of big data because it's not just powerful, it's surprisingly user-friendly and flexible. Spark can tackle a wide range of tasks, from simple queries to complex machine learning algorithms.
Okay, so Spark is like this versatile superstar ready to take on any challenge. But before we get into the ring, let's quickly break down what makes Spark so special. One of the key things that sets Spark apart is its speed. Compared to older technologies like Hadoop MapReduce, Spark can process data up to 100 times faster for certain applications.
Hold on, 100 times faster. That's like the Flash racing against a snail. What makes that possible?
Spark achieves this incredible speed by cleverly utilizing in-memory processing and optimized execution strategies. So instead of constantly reading and writing data to disk, Spark tries to keep as much data as possible in memory, which significantly speeds things up.
So it's like a wrestler who's always one step ahead,
Yeah.
anticipating their opponent's moves and reacting with, like, lightning speed.
Precisely. Spark is designed to be agile and efficient. Plus, it's not just about speed. Spark is also designed for ease of use. It provides simple and intuitive APIs in multiple languages, like Python, Scala, Java, and R, making it accessible to a wider range of users.
So even someone who isn't a coding champion can pick up Spark and start working with data effectively.
Absolutely. It's designed to be approachable, even for newcomers. Now, let's talk about Spark's modularity. Spark is built with a set of libraries that cater to different data processing needs, almost like a team of specialized wrestlers, each with their own unique skills and strengths.
So it's not a one-size-fits-all tool. It's more like a toolbox
Mm.
with different tools for different tasks. Can you give some examples of these libraries?
Of course, we have Spark SQL, which allows you to query structured data using familiar SQL syntax. Think of it as the technical wrestler who's a master strategist, utilizing precise moves and tactics. Then there's MLlib, which is all about machine learning. This is your powerhouse brawler, capable of crunching massive data sets to build predictive models.
So Spark SQL is for those who like to analyze data with precision and strategy, while MLlib is for the heavy hitters who want to extract insights and predictions from their data. What other libraries are in Spark's arsenal?
We also have structured streaming for handling real-time data streams. Think of this as the high-flying, agile wrestler who can adapt to changing situations in an instant. And for those who need to work with graphs and relationships, there's GraphX.
Okay, so Spark has a diverse team of specialists ready to handle all sorts of data challenges. It's starting to feel like we're building our own wrestling roster here.
Exactly. Now let's dive into Spark's distributed architecture. It's designed to work across a cluster of machines, enabling it to process vast amounts of data in parallel.
So instead of relying on one single machine, Spark spreads the workload across multiple machines, making it a true tag team champion, right?
Precisely. To understand this better, let's bring back our WWE analogy. Imagine Vince McMahon, the mastermind behind WWE, as the driver program. He's the one calling the shots, setting the overall strategy for the show, much like the driver program in Spark defines the data processing tasks.
And who are the wrestlers in this scenario?
Think of the executors as the wrestlers themselves. They're the ones in the ring actually executing the moves, processing the data according to the instructions given by the driver program.
So the driver program is like the coach or manager setting the strategy, and the executors are the players on the field putting the plan into action.
You got it. And of course, we need someone to handle the logistics, to make sure everything runs smoothly backstage. That's where the cluster manager comes in. It's like the backstage crew in WWE handling all the behind-the-scenes operations. The cluster manager ensures that resources are allocated effectively, tasks are distributed across the cluster, and everything runs as planned.
Okay, so we've got Vince McMahon setting the strategy, the backstage crew handling logistics, and the wrestlers in the ring doing the actual work. It's a well-oiled machine designed for maximum impact.
Exactly. And each component plays a critical role in Spark's success, just like in a well-produced WWE event.
Now, let's get into the heart of how Spark processes data. One of the fundamental concepts to understand is the difference between transformations and actions. This is where the wrestling analogy really shines.
Think of transformations as the rehearsals before a big match. The wrestlers are planning their moves, practicing their routines, but they're not actually executing them in the ring yet. They're essentially creating a blueprint for the match.
The transformations are all about setting the stage, getting the data prepped for the main event.
Precisely. And actions are when the bell rings, the crowd roars, and the match begins. That's when all the rehearsed moves, all those transformations come to life.
So if we were to write some Spark code, what would a transformation look like?
Let's say you have a data set of WWE wrestlers, and you want to filter that data to select only wrestlers who weigh over 250 pounds. That filtering operation is a transformation. You're not actually calculating anything yet. You're just defining how you want to transform the data.
So it's like selecting the wrestlers who qualify for a heavyweight title match.
Exactly. Now, an action would be something like counting how many wrestlers meet that weight criteria. That's when Spark actually performs the computation and gives you the result.
Okay, so transformations are like setting the rules of the match, and actions are like executing those rules to determine the winner.
That's a great way to put it. Now, Spark utilizes a clever concept called lazy evaluation to make this whole process super efficient. It's like The Undertaker making his grand, dramatic entrance, taking his time to build anticipation before finally stepping into the ring.
Lazy evaluation. So Spark is taking a page out of The Undertaker's playbook. How does that work?
Instead of executing each transformation immediately, Spark waits until an action is called. It analyzes the entire sequence of transformations, figures out the most efficient way to execute them, and then boom, it springs into action when an action is triggered.
So Spark doesn't rush into things. It takes a strategic approach, optimizing the entire process for maximum efficiency. It's like studying your opponent before making your move.
Precisely. And this lazy evaluation approach allows Spark to avoid unnecessary computations and deliver results with lightning speed.
Now, this is where things get even more interesting. We've talked about transformations in general, but there are actually two main types: narrow transformations and wide transformations.
Think of it this way. Narrow transformations are like a solo wrestler practicing their moves. They are self-contained, agile, and require no interaction with other wrestlers. A perfect example is filtering data based on a single column. Just like Rey Mysterio executing a perfectly timed 619, the input partition contributes directly to a single output partition, making it a straightforward operation.
Okay, that makes sense. So what about wide transformations? Are those more like tag team matches?
You got it. Wide transformations require coordination across multiple wrestlers, involving data shuffling between different partitions. Imagine the Shield's devastating triple powerbomb requiring perfect synchronization between all three members. Similarly, wide transformations in Spark, like grouping data by a specific key, require data to be shuffled and reorganized across different partitions. It's a more complex operation, but it can lead to some incredibly powerful results.
So narrow transformations are like solo moves, quick, efficient, and focused, while wide transformations are like tag team maneuvers, powerful, complex, and requiring coordination.
Exactly. Understanding this distinction is key to optimizing your Spark code and ensuring it runs as efficiently as possible. And we're back, ready to continue exploring Apache Spark through the exciting world of WWE.
It's amazing how this analogy is making me grasp these concepts. So far, we've seen Spark as this powerful, versatile engine for data processing, and we've explored the roles of its key components. We've also delved into the difference between transformations, which are like setting the stage for a match, and actions, which are like the match itself. And we've learned how Spark uses lazy evaluation to optimize execution, much like The Undertaker takes his sweet time to enter the ring, but then delivers a powerful performance.
Exactly. Now let's shift our focus to how Spark breaks down complex data processing tasks into smaller, more manageable units. Think of it as WrestleMania, the grandest stage of them all. But even WrestleMania is organized into individual matches, each with its own sequence of moves.
So how does this WrestleMania analogy apply to Spark?
Well, in Spark, a job is like the entire WrestleMania event. It represents the complete data processing task you want to accomplish. Each job is then divided into stages, which are like individual matches within WrestleMania. And each stage further breaks down into tasks, which are like the specific moves executed within a match.
Okay, so we have jobs, stages, and tasks. Can you elaborate on what each of those means in the context of Spark?
Sure. A job is the highest level unit of work in Spark. Let's say you want to analyze a massive data set of WWE match results to determine the most popular finishing moves. That entire analysis would be considered a job. Now, this job might involve multiple steps, such as reading the data, filtering it, grouping it, and then calculating the frequency of different finishing moves.
Hmm.
Each of these distinct steps, which can be executed without shuffling data between nodes, would be a stage.
So if a job is like WrestleMania, then a stage is like a specific match, like a singles match, tag team match, or a Royal Rumble, right?
Absolutely. And then within each stage, we have tasks, which are the smallest units of work executed by individual executors. Tasks are like these specific moves within a match, the punches, the kicks, the slams, and of course, the finishing moves.
Okay, I'm starting to see the whole picture here. We have jobs, which are the overall data processing tasks, broken down into stages, which are like distinct steps in the process, and then further divided into tasks, which are the atomic operations executed by individual executors.
Exactly. And just like a well-coordinated WrestleMania keeps a crowd engaged, Spark's ability to break down computations into smaller units ensures efficient parallel processing across the cluster, leading to faster results.
This is fascinating. It's like watching a well-choreographed wrestling match unfold, seeing how each move contributes to the overall narrative.
Hmm.
But how can we, as Spark users, monitor all this action? It sounds like it could get pretty complex.
You're right. It can get complex, but Spark provides us with an amazing tool to keep track of everything. The Spark UI. Think of it as our backstage pass to see what's happening behind the scenes, much like WWE's Titantron displaying real-time stats and visuals during a match.
So with the Spark UI, we can peek behind the curtain and see how our Spark applications are performing.
Exactly. We can see which jobs are running, how many stages are involved, the progress of each task, and even the resources being used by each executor. It's an incredibly valuable tool for debugging, performance tuning, and understanding how our Spark code is actually being executed.
It sounds like an essential tool for anyone working with Spark.
Yeah.
I can imagine it would be like having a team of analysts constantly monitoring the match, providing insights and recommendations to improve the performance.
Absolutely. Now, let's talk about Spark's evolution. In the early days, Spark primarily used resilient distributed data sets, or RDDs, as its main data abstraction. Imagine RDDs as the early days of wrestling. A bit chaotic, unpredictable, and lacking the structure and finesse of modern-day wrestling.
So RDDs were like like a wild west of data processing.
Exactly. While they were flexible and powerful, RDDs lacked some key features for efficient data handling. They were like a hardcore match with no disqualifications. Powerful, but sometimes unpredictable.
So what did Spark do to bring order to this chaos?
Spark introduced data frames. Think of data frames as the evolution of wrestling, moving from chaotic brawls to more structured and strategic matches governed by rules and regulations.
So data frames brought some much needed order and discipline to the world of Spark.
Precisely. Data frames are like modern-day matches with clear rules, weight classes, and championships. They provide structure and organization to your data, making it easier to process and analyze.
So how do data frames achieve this structure? What's the secret sauce?
Schemas. Schemas are the backbone of data frames, acting like championship belts in WWE. The championship belt defines the weight class and the title being contested, just like a schema defines the structure of your data. The names of the columns, the types of data each column holds, and the overall organization of the data.
So if we have a data frame representing WWE wrestlers, the schema would define columns like name, weight class, finishing move, and so on.
Exactly. It's like having a roster with all the key information about each wrestler, neatly organized and ready for analysis. And the beauty of schemas is that they enforce data integrity, ensuring that the data conforms to the defined structure.
So schemas act like referees, making sure everyone plays by the rules and the data stays clean and consistent.
You got it. And we can define these schemas in a couple of ways. We can either define them programmatically using code, or we can use DDL strings, which are like shorthand descriptions of our data structure. Think of them as those quick introductions you hear before a wrestling match, summarizing the wrestlers' backgrounds and achievements.
Okay, so we have data frames, which brings structure and organization to our data, and schemas, which define the blueprint for these data frames.
Yep.
But how do we actually work with the data within these data frames? It's like having a roster of wrestlers, but we need to know how to interact with them.
Exactly. And that's where columns, expressions, and rows come into play. Imagine a Royal Rumble match with 30 wrestlers battling it out in the ring. Each wrestler represents a column in our data frame, a specific attribute or piece of information about our data.
So if our data frame represents WWE wrestlers, then columns would be things like name, height, weight, finishing move, and so on.
Absolutely. And just like you can focus on specific wrestlers in a Royal Rumble, you can select specific columns in a data frame to work with. And here's where expressions come in. Expressions allow you to manipulate and combine columns to create new values or derive insights. It's like forming tag teams or alliances within the Royal Rumble.
So if we wanted to calculate the body mass index, or BMI,
Yeah.
for each wrestler, we could use an expression to combine the height and weight columns.
Exactly. You're creating a new column, BMI, based on existing columns. It's like having two wrestlers team up to execute a devastating double team maneuver.
Okay, so columns are like the individual wrestlers, and expressions allow us to manipulate and combine them in interesting ways. What about rows? Where do they fit into this analogy?
Rows represent the individual records in our data frame. Think of each row as a wrestler entering the Royal Rumble. Each wrestler has a set of attributes, columns with specific values. For example, one row might represent John Cena with values for his name, height, weight, finish and move, and so on. Another row might represent The Rock with his own set of values.
So if columns are like the characteristics we're tracking, rows are the individual instances of those characteristics.
Precisely. And just like in a Royal Rumble, where you might want to focus on a specific group of wrestlers, you can use filtering operations to select specific rows in a data frame. It's like the commentators highlighting the key players in the match.
This is starting to make so much sense. We have data frames, which are like structured matches governed by schemas, which are like the rules of the game. Within these data frames, we have columns, which are like the individual wrestlers, expressions, which allow us to manipulate and combine these wrestlers, and rows, which are like the individual entries in the match.
You got it. And now that we understand the building blocks of data frames, let's explore some of the common operations we can perform on them. It's like having a set of wrestling moves for manipulating data.
Okay, let's see what move Spark has in its arsenal. What are some of the essential data frame operations?
We have a wide range of operations, but some of the most common ones include filtering, grouping, sorting, and aggregations. Let's break those down, using our trusty WWE analogy, of course.
I'm ready for some data manipulation moves.
Filtering is like dodging an opponent's attack. You're selectively choosing data that meets specific criteria, filtering out the rest. Think of Rey Mysterio effortlessly dodging a charging opponent, gracefully evading danger. That's filtering in action. You might filter your data frame to select only wrestlers from a specific weight class or those with a certain win-loss record.
So filtering's like a defensive maneuver, protecting your data from irrelevant information.
Exactly. Now, grouping is like forming tag teams or alliances. You're bringing together data with similar characteristics. Imagine the Shield, a formidable force, combining their strengths to overpower their opponents. Grouping in Spark allows you to group wrestlers by their weight class, their finishing move, or any other attribute you're interested in.
So grouping helps us organize and categorize our data, like creating different divisions in WWE. What about sorting? How does that fit into our wrestling analogy?
Sorting is like ranking wrestlers based on their win-loss record or their championship reigns. Imagine those end-of-year rankings that determine who gets a shot at the title. Sorting in Spark allows you to arrange your data frame in ascending or descending order based on any column you choose. You can sort wrestlers by height, by weight, number of championships won, or any other metric.
So sorting helps us understand the hierarchy and order within our data, just like rankings determine the pecking order in WWE. Now, what about aggregations? Those sound powerful.
Aggregations are like calculating statistics for each wrestler or for groups of wrestlers. Think of those stats you see during a match: average strikes landed, takedowns secured, or even the percentage of successful signature moves. In Spark, you can perform aggregations like calculating the average height of wrestlers in each weight class, the total number of championships won by a particular wrestler, or even the most popular finishing move in a given year.
So aggregations are like data insights and summaries providing a deeper understanding of the data, just like wrestler stats provide insights into their strengths and weaknesses.
Exactly. And these are just a few of the many operations you can perform on data frames. It's like having an entire playbook of moves for manipulating and analyzing your data.
Wow, this is amazing. We've gone from understanding the basic components of Spark to seeing how it breaks down complex tasks, and now to manipulating data like seasoned wrestlers. But what happens if something goes wrong in this highly choreographed world of Spark? What if one of the nodes in our cluster crashes during a critical operation?
That's where Spark's fault tolerance comes in. Think of it as a resilient WWE superstar like John Cena, who can take a beating but always gets back up, stronger than ever.
So Spark has a never give up attitude.
Absolutely. Spark is designed to handle failures gracefully, ensuring that your data process and tasks can complete even if part of the system goes down.
And we're back for the final round of our Apache Spark deep dive.
It's been a journey exploring the world of big data through the lens of professional wrestling.
We've seen how Spark, like a seasoned WWE champion, can handle these massive data sets, process data with incredible speed, and even recover from setbacks like a true survivor.
We've uncovered how Spark's components work together seamlessly, much like a well-coordinated wrestling team, with the driver program as the strategic mastermind, the cluster manager as the efficient backstage crew, and the executors as the powerful wrestlers executing the moves.
We've also delved into the core concepts of transformations and actions, comparing them to the plan and execution of a wrestling match. And who can forget lazy evaluation, Spark's strategic approach to delaying execution for maximum efficiency, much like the Undertaker making a grand entrance before unleashing his power.
And let's not forget the evolution of Spark's data abstractions, right?
All right.
Moving from the chaotic world of RDDs, which we compared to hardcore wrestling matches, to the more structured and efficient world of data frames, governed by schemas that act like championship belts, defining the rules of the game.
It's amazing how this analogy has helped us grasp these complex concepts, making them relatable and even entertaining.
Absolutely. And we've also touched upon Spark's remarkable ability to handle real-time data streams, processing information as it arrives, just like the live action and dynamic nature of a WWE event.
We've seen how Spark leverages parallel processing, distributing the workload across multiple machines, like a well-coordinated tag team match, achieving incredible speed and efficiency.
And we've explored Spark's fault tolerance, its ability to recover from failures and keep going, much like a resilient wrestler bouncing back from a devastating move.
But before we declare a winner in this data processing showdown, let's recap some key takeaways for our listeners.
Sounds good.
First and foremost, Spark is an incredibly powerful and versatile tool for processing massive amounts of data. Whether you're dealing with batch processing, machine learning, real-time streaming, or graph analysis, Spark has a library to handle it. Much like a WWE roster boasts a diverse range of superstars with unique skills and abilities.
And remember, Spark's distributed architecture allows it to scale horizontally across clusters of machines, harnessing the power of parallel processing to tackle even the most demanding workloads.
Exactly. It's like having a whole team of wrestlers working together to achieve a common goal.
Understanding the difference between transformations and actions is crucial for writing efficient Spark code. Transformations are like setting up the plan, what actions are like executing the plan. And lazy evaluation ensures that Spark doesn't waste time or resources on unnecessary computations.
Precisely. It's all about being strategic and efficient, much like a skilled wrestler planning their moves and conserving their energy.
Data frames are the backbone of structured data processing in Spark. They provide a schema-based approach, making data manipulation and analysis more organized and efficient.
Think of data frames as the modern era of wrestling with clear rules, weight classes, and championships,
No.
bringing order and structure to the chaos.
And finally, Spark's integration with cloud platforms enables us to leverage the scalability and flexibility of the cloud for truly global data processing capabilities.
It's like having access to a global network of arenas, each hosting its own Spark events, all coordinated and managed through a central control center.
Exactly.
So what does this all mean for you? Why should you care about Apache Spark?
Spark is becoming increasingly essential in a world driven by data. It's used by companies of all sizes across various industries, from tech giants to financial institutions, healthcare providers to media companies.
If you're working with large data sets, if you need to perform complex data transformations, or if you want to unlock the potential of real-time data analysis, Spark is the tool for you.
And the best part is Spark is open source and has a vibrant community, so there are tons of resources available to help you get started and master this powerful technology.
We hope our WWE analogies have made this deep dive into Spark more engaging and memorable. Sometimes the best way to understand complex concepts is to find creative and relatable analogies, even if it means comparing data processing to a wrestling match.
Absolutely. It's all about finding ways to make learning fun and engaging.
So go forth and explore the world of Apache Spark. You might just discover a hidden passion for big data wrestling. Who knows? Maybe you'll even create your own analogies to help others understand this fascinating field.
And remember, in the world of data processing, as in WWE, the only limit is your imagination.
That's it for this deep dive. Thanks for joining us, and we'll see you in the next episode.